Okay, guys, so I thought I would try the homework with you in this way. We'll see how many problems I can do in about 5 minutes. I'm going to watch my time. So the first one says determine whether matrices are multiplicative inverses. The easiest way to know is to go ahead and multiply them out, and then what I should get is an identity matrix to know what their multiplicative inverse is. So I'm going to take the 2 times 3. I went ahead and drew my lines in. I've got 2 times 3 is 6. Plus 1 times -5 is -5. I'm going to go ahead and do the bottom piece down here, and that's 5 times 3 is 15, plus 3 times -5 is -15. All right, now I'm going to change colors and pick up a different color so we've got 2 different colors of blue. I'm going to do this and this one. So 2 times 1 is -2. 1 times 2 is +2. Then I'm going to do this one. 5 times -1, -5. 3 times 2 is 6. Okay, so if I go ahead and I add these together, I've got 6 plus -5, I get 1. I got 15 plus -15, 0. -2 plus 2, 0. And then 1 again. Would you look at that? That is the identity matrix. So yes, it works. All right. If you start this one here and here, and you go, okay, 4 times 1 is 4, plus 9 times -1/3 is -3. You see how you automatically get a 1 here? So right now the answer is yes. If the next number gives you a 0, then we're still a yes. As soon as you get anything other than what's going to give you the identity matrix, then you can go ahead and stop. All right, so I'm going to let you go ahead with some of these. I will get them finished up and I will color code all of them for you. Just so, to help you get this bottom one, 2 times 1 is 2. 6 times -1/3 is -2. So far I'm on the right path, but I'll finish it up later. Determine if the inverses exist for the following. All right, so what you have to do, the only reason one wouldn't exist, remember, is if the determinant of A is equal to 0. This is when it does not exist. Does not exist. Okay? So all I have to do here for the determinant, I'm just going to go up, grab another color. Let's make it bright orange. To find the determinant, all I have to do for this is multiply and then subtract this multiplication. So 4 times -1 is 4, minus, that's going to be 6 times 8, 48, -48. So that's 52. So yes, it does exist. All right, I didn't tell you to go ahead and find it. I just said, does it exist? If we went ahead and found it, then you would have to swap these, negate these. Okay, oh, and you can't tell when I'm doing that. Swap these. You know what, I'll make it in red. I don't have red. Let's go pink. And negate these. All right. All right, so it just said to determine if it exists. All right, moving on down the page. Evaluate the determinant of each matrix. Again, I just did the determinant, and it can be anything. And once you find it, find the inverse. So I'm going to go ahead, take these. This multiplies to give you 3 minus whatever this multiplies to give you, which is 4. So it's -1. So to find the inverse of that matrix, then what you're going to do is you're going to take -1, because this is actually 1 over -1, but that's the same as -1. Be careful, make sure you put it on the bottom. I wanted to write it out and not take a shortcut on you there. These two have to swap places, the first two. So we've got the first diagonal swap, -1, -3, negate the other two, -4. And that should be a matrix, not a determinant. So let's make it a matrix. Okay, finally, go ahead and multiply through by that -1. 1, 1, 4, 3. There you go. All right, find the determinant. The determinant is equal to 15 minus 9 times 3 is 27, which is, what can I think? 10, 12, negative 12. Okay, so what happens here is I should have said A inverse. The inverse of it is equal to 1 over negative 12. See, this one makes a bigger deal. The 12 is on the bottom. And then I'm going to have the matrix of these two swapped, 5, 3, and these two negated, negative 3, negative 9. Okay, so if I multiply through, that would give me negative 5/12. 3 over 12 becomes 1/4, and it is positive. Negative times negative is positive. 9/12, that reduces to 3/4, and it's going to be positive 3/4. And then 3/12 is going to be 1/4, and it's going to be a negative 1/4. Okay, there's its inverse. There you go. All right. So just wanted to do a couple of those. Again, I will finish it out, and I'm pushed for time. Solve each system. Okay, you can do these any way you want because it says by inverse or Cramer's rule. My absolute favorite is Cramer's rule, so I'm going to do it Cramer's rule. All right, so Cramer's rule, and I like my purple. Come back. And I did not want that to happen. Why did that happen? Select. My hair wet my nose. I don't know if I like having my picture on here. I get an itchy face. All right. I don't know why it's like that. I'm going to ignore it, and I'm just going to go right ahead. All right. I think I'm running out of juice. Negative 3. Okay. Let me just do Control Z. There we go. Maybe that'll fix it now. So negative 3, negative 3, negative 2, negative 4, X, Y. Okay, and this, you start it like this no matter how you want to do it. Okay, 9 and 16. Okay, so if you remember Cramer's rule, this is how you do it. To find the X, I am going to circle, let's go to green. I'm going to circle my X's. These are my X's right here. So I am going to find the determinant of not 3 and 2 with 3 and 4, but 9 and 16. So 9, 16, negative 3. I want to go back to purple, sorry. Negative 3, negative 4. All over, I want to go ahead and find the determinant of this. So if this is A, then the determinant of A is equal to, and that's really squished in there, this multiplied gives me 12, minus these multiplied gives me 6, and it's positive, so that's just a total of 6. So it's all over 6. I like that determinant because I'm going to use it twice. All right, so I've got this one set up, and I'm going to have to find the determinant. I'm going to go ahead and set up the other one while I'm setting up, and I want the determinant over 6 again. All right, using that 6, I told you get to use it twice. Then I'm going to grab another color, and this time I'm solving for the Y side. So that's going to get swapped out to your 9 and 16. And what happens is your negative 3, negative 2 stay in that place. All right, so going on, and I didn't mean to click on that. All right, so going on, I get 9 times 4 is negative 36. Minus negative 48. So that gives me, this becomes a positive. So that gives me a total of 12. 12 over 6 is 2. All right, and then finishing this one off, this determinant, that gives me negative 48. That gives me 18 plus, I'm sorry, it was a minus to begin with. This goes a minus, minus negative 18. That's where the plus comes in. You got the double negative. So that gives me a total of 30. So this gives me 30 over 6, which is 5. Any negatives in there? Yeah, that was a negative 30. I have to watch those negatives. So this is a negative 5. So here's your y. Here's your x. This is the way I like to do it. You could have done the other method, but I'm going to stop for now. All right.